Do you like to dance? Well, so do your cells. And just like you wouldn't waltz at the nightclub or have a rave in a ballroom, your cells, too, need to do the right dance at the right time and place. But what does it mean for cells to dance? Well, they can move, they can hold on to each other, and they can divide. When you develop as an embryo, these cellular dance moves often have to be highly coordinated, even if your dance moves aren't. Other times, though, cells dance individually, more like a cellular rave. Ultimately, when, where, and which of these cellular dances takes place is what shapes you into you. And nowhere is this more true than with your face. We're still figuring out exactly how healthy faces grow. Cell behaviors translate hundreds of genes into the huge variety of faces I see here today. But missteps in this dance can result in serious structural birth defects that make it harder for kids to eat, to speak, and really to be kids. My work tackles this by finally picking apart what cells are actually doing in the growing face. I use 3D imaging to look at patterns of key cell behaviors, especially cell division, in mouse embryos. The light sheet microscope that I use allows me to see what every individual cell is doing in a whole developing face, so I can understand how they help you grow. When I looked at where cells were dividing, the differences I saw were small. They weren't enough to explain why your face grows more in some places than others. But when I looked at the directions those cells were dividing in, there it was. Cells at the front of the early jaw divided forward, the direction the tissue grows the most. A cellular waltz, tight and coordinated. Cells in the sides of the jaw divided in random directions, more like a cellular rave. Ultimately, this balance of waltz and rave, coordinated and chaotic, just might be the key to growing a healthy face, unlocked by watching the dance of the cells.